Okay, everyone say hi, Isaac.
Hi, Isaac.
Oh, I'm probably going to say this.
He was very enthusiastic for that.
Is that who you're gonna make sure he watches the video? What does the class say?
Right?
What's the code word?
Did I get a high
Can we come up with a code word?
Code word for what?
Like a code word we say and he will make sure he's actually watching.
Tonight or tomorrow, I'll ask Isaac if not tonight, but he won't watch the video.
He won't watch it tonight.
Monday, I'll ask him if he could.
Okay, what's our code word?
Can it be something about my flash?
The turtle shell method.
Code word turtle shell.
Okay. I like that.
Okay, so please have patience through today. I'm going to show you some algebraic techniques that could help us when we evaluate an integral. Take, for example, 1 over 1 plus e to the x. How are we supposed to do? Okay. What is frustrating about this problem is that there's nothing for us to use for u substitution, right? What would be more helpful in our numerator if we wanted to use u substitution? E to the x. That would be more helpful, wouldn't it? Okay. So, what are we allowed to do? Multiply by 1 or add? Add how much? Add 0. Multiplying by 1 or adding 0 does not change our expression. What did I just do? I added 0. E to the x minus e to the x is what I added. Now, how is that beneficial? Okay, we're not quite ready for u substitution, but what we can do is we can break this apart into two integrals. We could break this up into 1 plus e to the x over 1 plus e to the x minus e to the x over 1 plus e to the x. Sneaky. Yeah. What is this right here? 1. And what's the antiderivative of 1? Minus. Over here now what can we do?
U substitution.
U can be our denominator, 1 plus e to the x. Du would be e to the x dx. There has been a fly in my room for the past 4 hours.
I tried to get it. It was like that. Pretty sure it's here.
It could have been here yesterday too. So there's our du over u. That's not u. Antiderivative? Say a letter. Natural log. So the natural log of u. Why didn't I put absolute value there?
Because they can't actually negate.
Okay, it's a positive function, 1 plus e to the x. We don't have to worry about the absolute value. Okay. All right. Now, the only way we are going to get better at using these random algebraic techniques is to do problems. All right. Now, what are some of the other techniques we are going to use? Ugh. What happened?
The gas method.
Yes. So dumb.
From what?
Chemistry.
Oh.
Called the gas method.
Can do for every single equation.
That's what I do in you.
All right, so we could expand the numerator separate fractions, complete the square, complete the square, divide improper fractions, we saw that yesterday, add or subtract terms in the numerator, use trig identities, and multiply by a Pythagorean conjugate. What?
Wait.
Yeah, I am.
Oh, so you should add and look at that.
What?
I'm not gonna remember all of these.
Oh.
Okay. That's the only thing I remember.
You can only really do stuff by multiplying by 1 or adding by 0. And then all the other ones are just that.
Recognizable. Okay. So this is where I'm going to need your help. I'm going to have you write down an example. And then I have you guys ever done poll everywhere?
Yeah.
Okay. You like text to join in the poll, and then you text an answer and it'll appear on the board. Okay, then you can't text?
No, my phone doesn't do
The random ones?
It doesn't do that.
Okay, so you and Alex can work together on her phone. Okay? And if you want to partner up at your tables, that's fine too. Okay? But what I first want you to do is write down this example. Not Snapchat. Write down the example.
It's just the soft side of his shoulder.
Because he doesn't do his face. Do we have it written down? Okay, so text carry home in 260 to 37607. And once you do, I want you to text in an answer to what strategy do you think would be best for this example.
Wait, is that all caps?
I mean, I don't know if it needs to be.
It doesn't need to be.
It doesn't need to be.
Oh.
Okay, so what strategy do you think would be best for this example?
So you haven't activated the whole yet.
I haven't activated it?
Yeah.
You get the message that says the message failed short opening and
You guys can get one that's fine.
Have you had success? This is sad.
Yep, not mine. Sorry.
Hold on. Just hold on. Now try. Ugh. What's going on?
You'll never spam me.
Okay, so it appears we have a winner, right? Well, I mean, look at the answers, right? We have a common one here, right? So we're gonna go back and look at the example. Sorry, I just wanted to make sure all of them were open. There we go. Okay, so if we cannot separate the fraction because there's only one term in the numerator. Okay, we can only separate a fraction if there's more than one term in the numerator. We can't separate a denominator. So our best bet is dividing our improper fraction. Okay, so I put my placeholders in, right? If there aren't, if we skip over a term or terms, we have to put zeros in. So x times what is x squared? Multiply x plus 1 times x. When we subtract, we're left with negative x. Okay. X times what is x? 1. Oh, but what did I do wrong? We want negative x, not positive x. Oh, come on. So negative x minus 1, and we are subtracting, so we have a remainder of 1. Do you agree? Okay. So we have the integral of x minus 1 plus 1 over x plus 1. Antiderivative of x.
1 half x squared.
Antiderivative of negative 1. Antiderivative of 1 over x plus 1. Let's see. Good. All right. Ready for your next one? Write down this example. This example. Shh. Okay, at your table, come up with an answer.
Oh, that's right.
Is it working? It should be the same text thread, right? I don't think so.
Oh wait, cosine squared plus 1 is
Are you guys texting in?
no.
You're doing
No, that's not a problem.
making sure it works.
What is the Pythagorean conjugate?
What is the Pythagorean conjugate? Well, first of all, can we get through this?
So it's not that.
You sent one in?
Maybe that doesn't give you a negative one. Oh wait, no.
There should definitely be more terms than should be.
No, that's it. That's it.
Yeah,
It gives me cosine of x.
What did you send in? Trig identities. Jake, did you send something in? What did you send in? This is really oh, there, it got to that one. Okay. So, trig identities will help us, but do we have a trig identity for cosine theta minus 1? Do we have a trig identity for cosine theta minus 1?
No.
What do we have a trig identity for?
Cosine squared.
Cosine squared theta minus 1. So, the Pythagorean conjugate of cosine theta minus 1 is cosine theta plus 1.
That's what that's called. Okay. Oh, okay.
Wait,
There's a name for that? No, I didn't. Okay.
Conjugates.
There's a name.
Inverse would be like cosine inverse. So we have cosine of theta plus 1 over cosine squared theta minus 1. What is cosine squared theta minus 1?
Sine squared theta. Negative sine squared theta.
Thank you.
That was cosine squared.
Negative sine squared theta. All right, so now we have to get a little creative. Not really.
Separate between or
Oh, and then you have to use that as u. That makes sense.
Okay, so we do need to separate cosine of theta over negative sine squared theta plus 1 over negative sine squared theta. Is there okay, so there's a couple different ways we can attack this problem. We can either use u substitution, or is it possible to rewrite it?
You can do cosine, cotangent.
Try again. You could do cotangent,
Times 1 over sine.
which is cosecant. Right? Cosine over sine is cotangent. 1 over sine is cosecant. So we could rewrite that to negative cotangent cosecant. Or you can use u substitution. What is 1 over sine squared the same as?
Cosecant squared.
Okay? Antiderivative of negative cotangent cosecant. Antiderivative of negative cosecant squared. Boom. No. Last one. It would be really cool if what was under the denominator. Like this would be better if we had like a squared minus x squared. Do you agree?
Yeah.
Okay. Let's force it to be a squared minus x squared. What strategy could we use under the radical to force it to be a squared minus something squared? Well, it's not going to help us because it's not going to follow the pattern that we want. We could completely split. Okay, so I'm going to take this over here and we're going to complete the square. So I'm going to write it as negative x squared plus 6x, right? We can only complete the square if we have a leading coefficient of positive 1. So I'm going to write this as negative x squared minus 6x plus a mystery number minus a mystery number. Just bringing back some memories. No? Okay.
Just the memories of four.
What's our mystery number? What completes the square? 9. And how do you get 9? Okay, b over 2 squared. Or maybe you just recognize the trinomial. Okay, so 6 over 2 squared is 9. Now, we added 9, but 9 is being multiplied to that negative, so we're really adding negative 9, which means we have to subtract negative 9. Whatever we add, we have to subtract because we're adding 0. Okay, so what we have is negative x minus 3, the quantity squared, plus 9. That's really the same as this right here. So we can rewrite our integral to be 3 over the square root. I'm going to write it, though, as 9 minus x minus 3, the quantity squared. Why would I do that? Okay, so it fits our pattern. Okay, now, since what is in here is A linear and B, the coefficient of x is 1, we wouldn't have to use u substitution. Now, if this were like 2x minus 3 or x squared squared, then we would have to use u substitution. But since the coefficient of x is 1, we wouldn't need to. This follows which pattern? Arc sine. So we have 3 from this 3. Arc sine of u over a.
That's very good.
And you know what? We're not going to do that one. I'm going to give you 10 minutes to start your homework. So I want you to do a couple of your homework problems. And then I'm going to give you the, you're going to have a Flashback Friday along with your book problems this weekend. Okay? But your Flashback Friday should take you about 10 minutes. I want you to do a couple of these problems.